Hey, how's it going everyone? It's Lee Halliday, and the project we're going to be working on in this video and the next is to build this resume. But the resume is a little bit different, where the data comes from a GraphQL API with this query right here that I'm displaying that's all about ourselves. So we're building our very own personal GraphQL API. And we're going to be building this in Next.js using Apollo Server. And we're going to be building our GraphQL schema using something called Nexus, which is a code-first schema approach. So if we were to take this URL and add on API GraphQL, we can actually pop over into the GraphQL API that powers this resume. So it's already got the query started here. It's bio, name. We could ask for my website, query that. We could add in my positions. Let's ask for sort of maybe the title for the last, I didn't load all of my jobs in here. I loaded like my last 5 or something like that. So this is what we're going to be building. In this part 1 of the video, we'll be starting with the back end because we need that in order to then move on to the front end where we can construct this resume here. And I'm going to be going through it step by step. I'll try to not miss anything so that I really want to encourage everyone to follow along, because when you're applying for jobs, A, it's important to have a resume, and it would sort of be cool if it was a resume built from your own GraphQL API. But B, it's important to have portfolio sites, work that you can show off to future employers. And this way, you're sort of killing 2 birds with 1 stone. You're going to get the portfolio piece that you can add into your GitHub, and also a resume. And you can tweak it however you want it to look like. You can add different data that I didn't add here. You can sort of make it into whatever you'd like it to be. Okay, so to get started, I'm going to pause this GraphQL, this Next.js app, and I'm going to go back a folder. So we're going to be doing it right from the very beginning. So I'm going to use npx to bootstrap a very bare bones, brand new Next.js app. So it's create next app, and then you have to give it a name. So we'll just call it the GraphQL resume. And so when you do this, it's going to be downloading all of the packages that you need to get up and running with Next. And that will take a second. Thanks again to AppSignal for partnering with me on this video. They just announced on their blog that they can now automatically instrument Apollo for Node.js applications. So head on over, check that out. And I wanted to talk about one of my favorite features, and that's the performance issues list. Here's where you can find the endpoints that are having the largest negative impact on your users. So impact means that there's a lot of throughput, but it's slow to respond. So clicking in, you can get a breakdown of where things are going slowly. Is it in GraphQL? Is it making too many requests to Redis? Or maybe too many queries to the database? And then down below, you can drill into what the actual details of this request are. If you'd like to use AppSignal, it is free for 1 month, and if you use the coupon code LEIGH, L-E-I-G-H, you'll get 10% off for your first year. Thanks again to AppSignal, and let's get back to this tutorial. With all of our packages installed, we can head into that folder, cd GraphQL resume, and then pop open VS Code. So this is what a bare bones Next.js application looks like. You've got the key folder here, pages, where we build out all the front-facing pages. So index.js, this would be our home page. And inside of the API folder is where you can build back-end pages, server pages, APIs. And this is where we'll be building our GraphQL API. So it comes with one called hello, but we're going to be replacing that with our own GraphQL one. So I'm going to start by renaming this to GraphQL.ts. We're going to be working with TypeScript today because that's where Nexus really shines. But we first need to install all of the packages that we're going to use for this demo. So I just pasted them in, and I'll go over each one. We've got Nexus Schema. This helps us build the GraphQL schema and resolvers all in one shot. It's a code-first approach. I'll talk a little bit more about that in a second. We've got Apollo Server Micro. So normally it's just Apollo Server, but because we're running it inside of a Next.js application, we have to use this micro one. We've got DateFNS because I'm doing some date subtraction to figure out how many years and months I've worked at each job from a start and an end date. We've got GraphQL, which is required by Apollo Server, GraphQL Scalars to define some custom scalar types, and I'll talk about those more later, and then Micro, which is just needed to help integrate Apollo Server into the app. So we'll install those. Hopefully it won't take too long. And then I'm going to install two more that are for using TypeScript, that Next.js will prompt me automatically whenever it sees me using a .ts file, but we'll just get ahead of the game and add those in. So the types for React and then TypeScript itself. So now we can start up this application. So first time it detected TypeScript in the project, so it created this tsconfig.json file for me. And I can just pop this open, and this is the brand new Next.js application. So we're not going to be doing much front end today at all. That will be in part 2 of this video. But if we hop over now, we'll start building out this GraphQL API. So I'm going to delete everything here, and I'm going to start by importing the Apollo server from Apollo Server Micro. So this is sort of Apollo Server in the micro form, and we need to set this up, create a new instance of it, and then tell it to start handling incoming requests. So we'll do that by setting up a server is equal to a new instance of Apollo Server. And here's where you can pass all sorts of options. We'll leave that blank for now and we'll come back to that. And now we need a handler. So the handler is what actually receives the request from the user. And we set that up by saying server.createHandler. And because we're not, typically GraphQL is just /GraphQL, but because ours runs in /API/GraphQL, we need to tell it what the path is. So we can say the path for this is going to be API/GraphQL. So with that, now what we can do is we can export default handler. And I'm actually missing a couple steps, but I'll show you the errors that took me a long time to figure out so that if you run into them yourself, you'll know what's what. So we can go over and head on over to the GraphQL API endpoint, and we get a beautiful internal server error. So if we hop here, we can see that Apollo Server requires either an existing schema, modules, or type defs. All right, so if you go and read about Apollo Server, getting started with Apollo Server, it will tell you set up, install dependencies, we've already done that. And then it will tell you to define your GraphQL schema. And you'll do that by using this GQL function, and you'll define sort of the blueprint of all the types of your GraphQL API. But then you'll have to come down, we've got our data, but then we have to define resolvers, how to load all of this data. So there's always two steps. You add a type, then you go and update the resolver. Type, resolver, type, resolver. I prefer to take the code first approach where you basically write code. It's sort of like writing your resolvers in a sense, but from this it generates the schema, the type, so you don't have to do that yourself. The GraphQL schema is an artifact of the code that you're typing. So that's what we're going to be doing with Apollo schema. So we need some types. So we're going to import from a file that doesn't exist yet, and we'll say import schema from src schema. And then we can pass the schema in here. So this won't work off the bat because I don't have an src folder, so let's go add one. And then we'll add our schema.ts file in here. But in order to sort of not say .. sort of get and then go into src schema, in order to do this, you need to add one option to your tsconfig. We need to come in here and say, I think it's called base URL dot. That basically tells TypeScript where to start looking. And when you do that, you can now just say src schema, and you don't have to do the .. etc. So I'm still getting an error because this file is empty and it doesn't do anything. Because I tweaked the TypeScript, I'm just going to restart my server just in case it needs a reboot in order to pick up those changes. So now that we're in our schema file, we can make the schema. So we'll do that by first importing the packages that we need. So import make schema from Nexus Schema. And then we can define and export this here. So export const schema is equal to make schema. So make schema is another place where you can pass a lot of options, but we're going to start with just passing the types. So any GraphQL API is made up of a series of types. So it starts with what things you can query, but then each piece of information that you can query, be it the bio of your resume, each position at a job you've had, that's also a type. So we need to define these types. It doesn't exist yet. So we'll import this from import star as types from all types. And I'll explain why the star as types in a second. So we need to create that folder. So this will be all types. And inside all types, we're going to start with an index.ts file. So why an index? This is going to be sort of the place where we import types from individual files. And the reason I like to do that is because if you start out organizing your GraphQL API well from the beginning, it will make your life a lot easier later down the road when it's massive. You could put it all in one file. That would work and be fine, but I like to put each type into its own file. So we'll leave this empty for now, and we will start with our query type. So query.ts. Okay, so this requires some additional imports. So we're going to import query type from Nexus. And query is always sort of the top level data type. They call it a root type sometimes. And there's a few of them that can exist. There's query, mutation, and I think subscribe is another one. But we're just going to have queries in this one because we're only reading data. So we need to define and export. Export const query is equal to our query type. Okay, so the way this works is that we have to build a definition. And definition is a function which is passed a t. And inside of here, we can define each of the fields that will allow our users to query. So we can actually get sort of a bare bones GraphQL API running by just saying something like t.string name, and we can just return Lee like that. So you now have a GraphQL API, well, not quite, but where you can ask for the name and it will return Lee. But we need to go back into index and we need to say export, how is this syntax? Export star as query from query. I think it's just this. Export star from query. So this index will basically import and then immediately export the file, everything that this query file exports. Sorry, I always forget this syntax for some reason. But now, because schema is now importing all of those types defined here, which imported our query, it should be good to go. So we can come back to this page. We can refresh it. And now we're able to query our API. So we can ask for the name, hit, and you'll see this thing just spin forever. And this tripped me up for I don't know how long. And funny enough, I found my own article which solved it, which is sort of funny. But that will never finish. So what we need to do is go back into our API file, and we need to export a config. Export const config, where we tell it to basically not parse the body of incoming requests. For some reason, if it does this, which is the default, it messes everything up. I guess, what did I mess up here? Equals. I guess the Apollo server handler is expecting to receive things in a raw format. So if it's already parsed, it doesn't know what to do. And if we do that, we can refresh the screen, query, and now we can get our name. So we've built out our GraphQL API, and now it's just a matter of adding a whole bunch of data for it. So let's keep going and add in the additional types here. So what is our query going to be comprised of? It's going to be comprised firstly of a bio and then all of the positions that I've worked at. So we need some data for that. I'm not gonna make you watch me type out all of these this data one by one, but I'll copy it over and then explain how it works. So I'm gonna put that in the src, data.ts, paste this in. So this at one point may come from a database or a CMS or something like that, but I've put all of this data right here into JavaScript. So I've got my bio where I've defined my name, my tagline like full stack developer, my contact information, what skills I have, Spanish speaking, certified coffee grower, Visual Basic 6, and then the positions. And I just started with my most recent one, and I went back, I think about 5 years. Basically just copying and pasting stuff from LinkedIn. But this is the data that we're going to be building our GraphQL API from. So we're going to start by building out the bio, and we'll do that by coming over to query. And rather than being able to query the name, we'll say that you can query a field called bio, and then we have to define some information about that. Because it doesn't know what type of data this is yet, we have to say that this is going to be a type of bio. And that doesn't exist yet because we need to go and declare that bio type. I don't know what a biquad filter is. Okay, so we've got our type, and we also need to tell it how to find this data. So we can say, here's how to resolve it. Here's how to load this data. So to load this data, it's an arrow function. It can be async if you'd like. And you can also receive 3 things that are passed here. You're always passed in the resolver the parent. Because this is the top level type, there is no parent really, so you could just say it's the root. You're passed any arguments. Here we're not receiving any, but you're also passed the context. Context is like a global object that gets passed around from to every single resolver, and that's where you might have your connection to the database, or maybe which users authenticated, things like that. But we don't need any of this, and it's not asynchronous. So here's where we'll load the data.bio. So I just need to import, is it default? No, it's not. Import data from, we can say src data, and this will be data.bio, like that. So bio doesn't exist, so I'm going to import it from the index file. So it's not there yet, so we'll need to first add it, but that's where it will be coming from. So I'm going to come in here and I'm going to create bio.ts, and we need to declare this type. So to do that, we need to import some things from Nexus Schema, just like that. And the one we need to import is object type. So now we can declare our bio. So export const bio is an object type, just like that. We give it a name of bio, and then we define its definition. So just as before, it receives a T, and this is where we define all of the different fields that this type of data has. So let's just add in the name at the beginning, so string name. And this is actually all we need to do. We don't need to build a resolver because it's going to receive this data here, because that's what we passed it from the query, its parent. So because you're just accessing a property, you don't have to define a resolver when you're just doing that. You can just leave it as is. So I'm exporting this from bio. So we go into our index file and we export star from bio. And because we're now exporting this from the index, our query should now work because it's importing bio from the index. So now we should be able to go back into our website, and we should be able to now ask for the bio name. Sweet. So we're now getting some data. We can head over to the docs and we can go and see what data our bio has. We can take a look at the schema that's being generated, and it's starting to look good. So let me just close this, and we'll just build out the rest of this. So what other fields does our bio have? It has all of these. So I'm going to copy them so I don't forget. Cool. So it's got a tagline, which is a string. It's got an email, which is a string. And then it's got 3 URLs. So I'm actually going to declare these as URL types. And to do that, why don't we just get through all the strings first? So t.string objective, like that. So to do that, we're left with these 3 remaining ones. What I want to do is say t.url, and we'll say GitHub, and the resolver for this will receive the parent. So the parent inside of the bio is the bio data itself, and we can just ask for the bio.github. But because we want this as a URL, we can say new URL and just wrap that like this. Cool. So I will do that for the other 2. So we got website and we've got LinkedIn. Clean up this code. So we're getting a type error, and it's going to say URL doesn't exist. So Nexus Schema doesn't come with URL sort of right off the bat. It's a new type that we need to add. So GraphQL by default comes with a number of what are called scalar types, sort of the most simple types. It's got like string, integer, float, Boolean. We want to add in a new scalar type called a URL. And while we're at it, we'll also add one for date as well. So the place we will define that is in this file actually. So we're going to import something called decorate type from Nexus Schema. We're also going to import something from GraphQL Scalars. So this is a package that basically defines a whole bunch of really base GraphQL scalars that don't come in GraphQL by default. So here we can grab GraphQL date and GraphQL URL. Those are the 2 that we're going to be adding. And the way that you define these new scalars is you say export const GQL date is equal to decorate type. And then the first thing you pass is the type that it's decorating. And then we have to give it a little bit of information for Nexus. So what is the root typing of this? It's the date. And how are we going to access this in Nexus? So this will be accessed with date. And that will make a little bit more sense once I do the same thing for URL. So URL, 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 URL. Cool. So what this has done is it's basically given an extra method that you can call when you're defining your schema. So if we were to come up here, it should start to say that this is a valid type, but it doesn't. So I think this is where we need to go and give Nexus a little bit more information about what types it's working with. So the way we'll do that is we'll go over to the schema, and Nexus, it sort of shines with TypeScript, but can be a little bit of a pain to set up. So first things first is I'm going to create a folder called generated. And what it's going to do is basically generate all of the types that Nexus is going to be using. Okay, so the way we can do that is we can tell it where to output all of the different things it's going to generate. So it's going to generate two things. We're going to save our GraphQL schema. I like to commit the schema into the repository so that whenever you're tweaking it, you can pick those up in your Git diffs, so you know what's actually going on with your API. So we're going to be outputting schema and then our type generation. But in order to do that, we need something from path. So import path from path. This is a node for working with the file system. So we're going to use path.join. And we're going to be joining two things. The first thing is we're going to join the current working directory where we're in. So normally you do like _ dir name. This doesn't work with Next.js very well from what I found. So what I found does work is this process.current working directory. And basically that will be wherever your next dev command is running, which would be your root of this. So if we want to put the schema right in the root folder, we can just say put it in schema.graphql like that. And you can see right away it creates this folder or this file schema.graphql. And this is our GraphQL schema that Apollo wants us to type by hand. Type bio each field, what type of data is, whether it's going to be null or not. So bang means it's non-nullable. The different scalar types that we've defined. That's what I want to avoid, typing all of this by hand. And the next thing we wanted to do is output our type gen. So same thing, path.join process.cwd. And we are going to put this inside of src generated nexus.ts. Just like that. So when this runs inside of generated, it's going to create us automatically all of these TypeScript type definitions. So you don't have to worry about too much of this here, but those are fine to work with. Okay, so what's it telling us? GitHub does not exist on email, name, objective, tagline, etc. So the thing it's struggling with now, it fixed this URL thing, that's working now. But it doesn't know what type of data this bio information is. And because of that, it's struggling to sort of understand what's happening and it's giving you errors, etc. So there's another thing we can do in schema, which basically gives it some hints about what type of data we're working with. So if it were coming from like Prisma, hopefully this is auto-generated for you, but we are going to generate just some TypeScript data for the two main pieces we're working with, our bio and each of our positions. So we'll do that in a file called, we'll just call it interfaces.ts, where we will define and export an interface for bio. So we know bio has a name, which is a string. It has, I'm gonna not try to memorize all of that. Okay, it's got a tagline, which is a string, an email, string, everything's a string. And the GitHub website and LinkedIn are all converted into URLs, but they start as a string. Because your database, for example, doesn't have a type called a URL. It's a string and you can convert it into other types. Objective is a string. So none of these fields are optional. And since we're here, why don't we just define our interface for our position as well? So each position has all of this. So ID is a string. If your ID is coming from a database, it might be an integer, but that's fine. Title is a string. Company, string. Start date, string. End date is optionally a string, because if you're still working at a job, it hasn't ended yet. Employment type, I'm not even going to worry about that. I ended up not using it. Location is a string, and then achievements are an array of strings. So with the interfaces defined, you basically need to tell Nexus where to find these so that it knows what data that it's working with. So we can do that by going back to our schema definition, and here is where we add in an option called typegen autoconfig. So the way this works is you define some sources of where to load type information from. So this could, as I mentioned, come from Prisma if you're loading things from a database and you already have types generated for your database. Or like in our case, we can define them here and just tell Nexus where to load those from. So we want to give it an alias. We'll give it faces for the interfaces. We need to tell it where to load that data from. So again, it's path.join, process.currentWorking directory, and then it is in src interfaces.ts. And then the last thing we need to do is basically tell it how to connect a type of bio to our bio interface. Like, what's the connection between there? And it's obviously that the first part matches the name of it, and then it's followed by the word interface. But we need to spell that out for Nexus. So you do that by saying type match. It's a function where you're given the type, and then your responsibility is to return a regex that tells it how to match. So we're going to be doing like this, where we embed the type and then we follow it with the word interface, like that. So I did something wrong. It's an object. There we go. And it's not math, it's match. That's the nice thing about TypeScript. Sometimes it's a real pain in the rear end because it's like so much extra work, but it saves you stupid little things like this, trying to figure out why type math didn't work. And just like that. And there's one small extra thing we can do is we can say backing type map. So those extra types that we added in, because those align with already existing node types, we can just say whenever you see the date, it's actually a date type in JavaScript. And whenever you see a URL, it's a URL type. Now, this on its own can be a little bit hard to debug, figuring out what's going on. Is it matching the types correctly? You can see it is because it went green already. It's now really happy, and it knows that this thing I'm receiving here is a string. But we can add in some debugging where if it's process.env, if we're in development, let's throw on some debugging. And what that will do, if we go into the terminal, is it will give you some output here to say the schema match type bio in this interfaces file on faces. That was my alias.bio interface. So here you can see when you've got like a match or a mismatch. So if I mess this up, didn't spell interface right, it would say no match found using, and it shows you the regular expression it used that it didn't match on. So that's pretty handy. Even though it's quite a bit of work to set up at the beginning, it's sort of something you have to do once. And now you've got a type-safe GraphQL API all the way out. So we've got our bio built already. We could come back here and we could add in our tagline. We could add in our objective, our LinkedIn, our GitHub, our website. I think that was everything. Email. It's not my real email address, but. So our bio is done. Next thing we're going to work on is adding in our positions. And then I think we're basically done the first part of this, where we build out the back end part of this. And then we could come, it's not showing anymore, and build out the front part of the resume. So why don't we go build the position type. Position.ts, we need to import object type from Nexus Schema. Oops. Like that. Then we need to define and export the type. So export const position is equal to object type. So we can give it the name of position, and then we can define the definition, which includes all of the different fields that it's going to have. So the fields that this has are, if we go and look at our data, so we've got our ID, title, company, start date. Why don't we just start with those ones? So t.id, and ID is an actual type in TypeScript, and it could be a string or an integer. It doesn't really matter which. So we've got an ID called ID. We've got our string called title. We've got our, forgot already, company. We've got our start date and our end date. So what we can do is we can do date, start, date. And here's where we have to do some resolving. So position, because we're storing it as a string, but it wants it as a date, we need to convert it into one. So we can just do new date position.start date, and that will convert it into the correct data. So next thing is our end date. But remember that end date is optional because you may still be working at a place. So why don't we put a ternary here to say, if there is an end date, then return that. Otherwise, return null. It's a nullable field. And because it's optional, we need to pass in an additional option. And the way that works is, I'm just actually going to cut this for a sec. We're actually going to have to do it within an object because we're passing more than just the resolver. So we're going to say nullable true, and here is how to resolve it. Okay, and I don't need that. There we go. So that's our end date. We can't actually use any of this data yet though, for a couple of reasons. First reason is we didn't import into our types here. So export star from position. But also because we never gave our query a way to find the positions. So we need to define that on the query object. So we can say it's a list of fields. We'll call it positions. And we will put an object where what type is each one of these going to be? It's going to be a position. And it did figure out how to import it from us, but we can hop this up to the index just to make it less code. And we need to tell it how to resolve this. So the way you resolve this is data.positions. That's how you access the array of the positions. And with that done, we can go back to our GraphQL, and we can now ask for, if we just refresh, all of the different positions. So positions, let me get the ID, the title, and the company. There we go. We can ask for the start date, the end date, query that. And you can see this one is null. Here's a little tip. If we go back to position, say we said nullable false, which is I think the default. If we were to query this, we actually get an error. Cannot return a null value for a non-nullable field, position.endDate. So it doesn't like that at all. It gives you a 500 error. So you need to say that whether it's nullable or not, or you need to provide some sort of fallback. But we are just going to say that it's nullable. Cool. So there were a few more fields that we needed to add, and then I think we're done. But I wanted to show one other thing on query as well. Why don't we do that first? I wanted to show how you can use arguments, how you can pass in data to help you find what you're looking for. So let's say we wanted to be able to look up a position by its ID. So we would have a field called position, which is a type of position. And then we need to tell it how to resolve. But before we do that, we have to define what sort of arguments can this field receive. So we say args, and it's going to receive an ID. And there's actually a function you can import called ID_arg that you call here. So now we're able to pass in an argument to a field, and I'll show you how that works in a second. But our resolver now looks like this. So actually I'll do it in auto return. So we've got our root, our parent, which we're not using because there isn't really a root when you're talking about your query. The root only comes into play when you're talking with one of the lower types where it does have a parent. But we have access to the args, which is what we want, and the context. Because we only want the ID, we can say ID like this. And right now it thinks it's an any. We could come here and say that the ID is going to be a string like that. So sort of add types to this little sort of inline interface that I'm declaring here. So how do you actually find these? We would take the data.positions and we would call the find function, where we're given each position, and we need to check if the position.id is triple equals to the incoming argument. Just like that. So with this in place, hopefully we can come back to our GraphQL API, and we could say, find me position with an ID of 1, and give me the title. So there we go, Director of Engineering. It's showing up right here. There's only one thing. What happens if you pass a 5, which doesn't, 5 exists. 8 doesn't exist. Boom, it fails again because it couldn't find that position and it cannot return a null for a non-nullable field. So we would need to go back and say nullable is true, because there's a chance you may not find the position that you're looking for, in which case it will just show up as null. So let's just go finish out our position API, or our position type. We need to add in some additional fields. The fields we'll be adding is years. How many years have you worked there? How many months have you worked there? And what are your achievements? So years, this will be an integer, an int, we'll call it years, and we need our resolver, just like this. So we are going to resolve the data with our position, but in order to calculate years, you basically need to find out the difference between today's date and when you started. So to do that, I am going to rely on datefns, date functions. And they've got some functions that are called difference in years and difference in months, which is super handy. So we need to find out the difference between the end date and the start date. But remember that the end date may be empty. So we could actually come in here and say end date and start date, just to make it a little bit easier on us. So end date may be missing, right? Difference in years, we need to pass 2 dates. So what we need to do is first check if there's an end date. And if there is, we can convert that string into a date. Otherwise, why don't we just use today's date? Like that. So that's the first one. The second one is the start date, which does exist, so we can just put start date in there and save. So it looks a little bit easier when Prettier cleans this up. We've got difference in years. It's the difference between the end date, which may be empty, so we need to check and handle null cases accordingly, and the start date. And why don't we just check to see if this is working? Let's ask for the years. 0, 0, 2, 1. Cool. It shows up as 0 when it's not a full year. It comes back as an integer, so it only shows you full values. So I think that's working. So why don't we work on months? So months will be very similar, where we've got the end date and the start date. And I am going to copy and paste this because save everyone some time. And we'll just change it to difference in months, like this. So if we come back, we now look at months. So I've been at my current sort of title for 9 months. And you can come down here and you can see that this 2 years is showing up as 26 months. So I don't think you'd want to include all of your years as months, because that's sort of weird. You want to say 2 years and 2 months, not 26 months. So what we can do is basically use the modulos operator to get the remainder, where we basically just get rid of all of the years by modulosing it by 12 months. So now when we come back, if we scroll down to that same one, we've got, at this title, I was 2 years, 2 months, which is great. So the last one is the achievements. So this is a list of strings called the achievements. And did I mess this up? It's just not happy yet. So this gets the position, and it returns the position.achievements, like that. Something's wrong. What did I mess up? No, it's not. It's good. Cool. So let me just query those and make sure that it's working. We'll ask for the achievements. There we go. So it's got an array of strings showing up on each of the positions. So we've built out our GraphQL API from start to finish. I'll do like a quick recap in a second, but we'll start at the beginning of sort of where we started going down the rabbit hole. We started out in Next.js converting this API endpoint to be for the Apollo server. We gave it the correct path. We fixed this body parser error. But the Apollo server needs the schema because we're not defining both our type definitions and our resolvers. Schema came from this file here, which is a big monster now, but it started out as just give me the types that this schema is made of. So types came from this all types folder, which included the custom scalars that we added in, plus our query type, our bio type, and our position type. So we then went and defined our query, which is basically how to find the data at the top level of where your GraphQL API starts. So we loaded the bio, the positions, and we did this one that allows you to find a position by its ID. And all of these you can add in a description as well, which is probably something you should be doing. So find a position by its ID. And the reason you would want to do that is because inside of your GraphQL schema, it should, once it auto-generates, there we go, it includes these descriptions in your schema. And because that's there, if you load up the docs and we go into position, it shows the description here. So every single field, both on your query and each of your types, should ideally have a description telling you what sort of data it includes. And just to, maybe we should add that and show you how that works. If you're going to add a description, you can't pass in the resolver as the second argument here. You'd have to pass in an object that has a description. When I started at this position, and you'd have to pass in a resolve like that. So I just added a description to the start date. So if I were to load this up again, find my position, start date, when I started at this position. And it also gives you some details about the type as well, because this is a type of date. So that's pretty cool. So we defined our query, which allowed us to find all of the data, and then we defined how each of these types resolves. And in the process of this, we basically built out our type definitions and our resolvers in one single place. So whenever we're adding a new field, we don't have to remember to do that in both places. And that's that. Hope you enjoyed this video. I'll be coming back with part 2 of this, where we build out the front end using Apollo Client, and it will look just like the one that I showed at the beginning of this video. Hope you enjoyed it. Take care. Bye.